Cool. Hi, everybody. My name is Vikram. I'm a productivity engineer working with the Angular team. Essentially, that means I help like the Angular team and users of Angular move fast without breaking things. Right? That's the primary goal, so that people are productive and are not slowed down by while they are developing their application. And major part of that is essentially being able to write your unit tests and end-to-end tests more easily, and so that you can keep evolving your application without always worrying whether it's going to work or not. So today I'm going to talk just about unit test, and essentially, I just want to give a background of like there have been a lot of changes that has been happening on the testing API side of things. So Angular 2 final happened, and essentially the motivation behind the changes that we did for the testing APIs are around like decreasing the number of concepts that you have to understand while you write the unit test, and also decrease the amount of boilerplate that you have to write. And we also did some work to make things independent of the test framework. So it was initially very much tied to Jasmine. Now you can use Mocha or whatever test framework you are comfortable with. And then the other major thing that happened was essentially ng modules, right? So essentially now tests have to understand ng modules, and in a sense that your test has its own ng module environment in which your unit tests run. So there are a lot of things that I can talk about the unit test, how to do different types of like unit tests and stuff like that, but and the concepts behind it, and you'd have heard Julie talk about some of like the concepts and zones and how we use it. But for this talk, I want to keep it like the message I want to convey is essentially like what are the decisions you would essentially take while you are designing your unit tests. And just go through some common testing recipes, like what are the common situations that you'll encounter in an Angular application, and what are like the standard solutions that we have. So hopefully that'll make it easier for you to just start writing unit tests, and like once you are doing more of that, you'll understand more of the concepts as you use more of that probably. So in terms of decisions, the higher level ones, the first decision is, hey, should I write unit tests, right? And there are two answers to that, yes and yes, right? Hopefully it's the second one. What frameworks you use, and this is like completely up to you, whatever you are comfortable with. Currently we have Angular team itself uses Jasmine a lot. And we have definitely like made it such that it can work with Mocha. We haven't tried anything else, but it should work with any of the test framework that you choose to use. And then the test runner, again, the Angular team has a preference for Karma, but again, if you have a preference for some other JavaScript test runner, you should be able to use it. So once you have decided these higher level things, then you would make decisions regarding your Angular application specific things. Essentially the main thing is how you would test, like set up the testing module for your unit test. And in the sense, the testing module essentially is the ng module equivalent for your test that provides the context in which your unit test runs. And in general, the main idea of a unit test is you would want to test things in isolation, right? And you mock out the dependencies of what you're trying to test. So then you have to decide how much do I mock? Do I mock all the dependencies, or do I mock just enough, right? And those are the two sides of the spectrum. And so you decide whether you want to test everything in isolation, or you are more comfortable with testing things more, as it is more closer in production, right? And again, this is something that you would decide what works for you best. Some teams in Google feel more comfortable like mocking as less as possible, and they want to be the test to run like in an environment that's much closer to production. But that also means that like it might be more difficult to debug when things fail, or things run slower, right? So it's, again, it's something you'll have to decide. And going even more specific to your test, so you would have like to make a decision at like for a particular unit test, whether it's going to be synchronous, which is the first thing, or asynchronous. Again, if you want to run your unit test similar to how your Angular application is running, you might want your unit test to actually use the browser event queue, and then naturally it'll be asynchronous, and you can do that. We also provide the fake async wrapper, which essentially, using zones, can capture the asynchronous events being scheduled, and then you can make it progress through the event queue in a controlled manner in a synchronous fashion. And maybe that's something that you feel more comfortable doing in a unit test. So again, these are the kind of decisions you would have to take. And again, within Google, we sort of say, hey, if something works for you in the asynchronous mode, do it because it's more closer to production. And if it is something that absolutely requires fake async, like if your component is actually waiting for 5 seconds, making your unit test run for 5 seconds is not an option, and in which case we would use fake async. But maybe for you, going fake async all the way through every time might be the thing you'd want to do. So once you're sort of decided about these things, you'd set up probably the guidelines for your team. So the next things are essentially, these are pretty simple actually. So you would have to have a way to locate the elements in your unit test as you're trying to test your component. There might be a button, and then you need a way to locate the button in your test and click it. So there are two options. And mostly actually we suggest using the DOM API as much as possible. Again, it's closer to what happens in the browser. But we also provide like the debug element in the unit test if you have done around that. And as we move towards like writing components that run not only on the browser but also in different environments like web worker or server side, you might want to write your tests in environment agnostic manner, in which case you do more of the debug element stuff. So, but if you are mostly just doing browser stuff, I'd say just stick to the DOM API. So, so that sort of takes care of like, hey, like what are the different options that the unit test framework in Angular gives me, right? And once you are pretty sure, like I just want to go through like different like common scenarios, kinds of components that you would want to unit test. So I created some Plunker projects for each one of these. So essentially, just have like a sandbox environment where we can check out the test and hopefully it's run. So just to start with, I just started out with a very simple component. This does nothing. Like, but what it has is essentially a template URL so it's external to the component, right? So you have a separate template URL which is probably have to be fetched or while running the test. So I just want to go over some of the basics by going through the unit test for this component. So the pattern that I would suggest using is essentially trying to encapsulate most of the async work in the test setup, right? So you have a before each, and you have essentially, so every unit test, as I said, has the ng module equivalent, which you can configure using the configured testing module. And here it imports the same module that the actual app uses. And then you call testbed.compile components, right? What this does is it essentially pre-compiles all the components that are available in the module that you specify above. And if any one of them has essentially a template URL, the test would actually have to fetch it using XHR. And all these are like inherently async operations. So testbed.compile components is actually returning a promise. It should complete when all the things have been fetched and pre-compiled, right? So the way you would wait for something like that to finish is using the async wrapper. So anywhere in your test, yes. Is that good? All right, so this is why I had it in the slide. So is this more readable? Yeah, okay, all right. So yeah, essentially you have the, the three main things are like you have the configure testing module and the compile components and an async. So maybe you can, I'll share this, the URL of the plunker and you can play around with it. So my hope is like, hey, when you go and you do your unit test, you can probably start copying stuff from the plunker and start doing stuff. So, so the async test wrapper essentially uses zones to keep track of all the async tasks that are pending after its body is completed. So it would essentially, you would configure testing module run, and then that's a synchronous operation, and then compile components will run. That might start a lot of async operations, and essentially the async wrapper would wait for all of them. So, and then in your actual test method, you would have like, have a way to create the component that you want to test, and that returns something we call a fixture. Every time you want some change in your component to be reflected back in the DOM, you call detect changes. So it's essentially running the same change detection that Angular runs in production, right? And in your unit tests, you have more control of when that has to run. And then Fixture has two separate kinds of elements. As I said, there's a DOM element and then there's a debug element. Here, I'm just using the native element, this is the DOM element, and then making sure, hey, everything was displayed properly, right? So going to a slightly more complicated example. So let's say you have a component that has a service injected into it, and that service is actually making a call to a backend service to fetch something, right? So let's see again if this. So I mean, essentially, this is a component. I didn't have time to do any of the CSS stuff. Essentially, there's a button. If you click on it, it's making a call to the backend and getting some user details. There's the username and the motto, essentially, for each user. So if we see like how the component is set up, so essentially the component has a user service injected into it. Right. Is this readable now, or do you need something bigger? Sorry, I didn't understand, but is this readable or? Yes. All right, okay. So, so you have a user service that's injected, and essentially all it's doing is when you click, when you click, it's essentially calling the get users and then displaying that in a ng-for, right? And then the user service itself is essentially using HTTP module from Angular to actually do the HTTP get, and then I'm not good with RxJS, so I just convert it into a promise and then display it. So that's essentially the basic component that you're trying to test. And here, so what I want to essentially show is you can instantiate the module as it is in your test, but then there's a way to override the module bindings. So here in this case, we want to test only the user component in isolation, and we want to mock out the user service itself, right? We don't care about that in the components unit test. So we say, hey, I'm going to override the providers for the user service, and then I use a mock user service there, which is completely controllable. I just provide like a mock get user call and do it. So and then essentially I wanted to show like how to locate different objects in your fixture. Once you click the button, it has essentially so in order to click the button, you have to find where the button is. So you can do it either using the debug element and using its query function. It has a little bit more flexibility in the sense you can query by actual directive type. So if you have one component embedded with another, you can just say query by directive and then the type that you're looking for, and that might be more convenient. Or you can just use DOM APIs. So you can just say fixture.native element and then use DOM APIs to query your DOM tree. So you can use whichever is convenient for you. And triggering the event, again, you can dispatch the event through the DOM APIs, or we provide like a trigger event handler on the debug element, which you can use to trigger. It doesn't make difference like how you trigger. Essentially, the way we set up when you trigger these elements, events through an actual click, a DOM event, it will automatically prime the like the Angular zone to run change detection too. So. And then finally, I wrote 2 versions of the same test essentially for this. Again, as I said, you can decide what will work best for you. This is the asynchronous version. So in this case, we click the button, and then even though we mocked out the get users call to just return something that we set up in the test, it's still something that returns a promise that has to resolve, and it takes a tick to essentially complete. So before this, like if you try to call detect changes, it wouldn't be ready to essentially, it's in a different microtask, so we need to wait for that to complete essentially. So in our testing framework, the fixture has something called a when stable. It essentially waits for all the microtasks to get drained and wait for Angular to become stable. And this is like a similar mechanism to what Protractor uses essentially. So it sort of makes it easier for you to like have a mapping between your unit tests and Protractor tests. So so you can wait for Angular to become stable, and that is again something that returns a promise. And then so you have a .then, and you continue with your tests within the then, right? And the thing is, again, since we use the async wrapper for the test here, you don't have to keep returning the promises that you are generating within your test, right? You can do as many asynchronous operations you want in your test. And the async wrapper will make sure you wait for all of them before it continues. So it makes it much easier to do it. So, and this is a fake async version of the same thing. So you click the element, and then instead of calling when stable, you say tick. And so since it intercepts all the asynchronous tasks through zones, we can control how it's drained. So a tick will essentially simulate like a passage of like one tick, and everything is synchronous at that point in your test. So again, you can decide which one you're comfortable with. Our recommendation is go async as long as it's like your tests run fast. But if your code has some actual set timeouts and things like that, then you might want to consider using fake async. So we tested the component, right? But we have code in the service itself now that's not tested. So we'd want to have unit tests to cover that too. So again, like, let me see. So if you go to use service, it's essentially taking the HTTP object, and it's doing something here. Maybe there's some more logic here that you want to test. This one is pretty simple, but so I just want to show you like the HTTP testing utilities that we have to do it. So you import the mock backend from HTTP testing, and again you can set the providers in the module. Here I didn't reuse the app module, so I'm just relisting all of the imports and the providers. So essentially I'm saying, hey, instead of like the regular backend, use the mock backend, right? And what that lets you do is control what the HTTP module returns, so you can control the exact response that it returns. And again, if your service has some more logic in there, you essentially test it using that. The next thing is routing. I didn't put too much into it. There's a lot more we can do with testing routers, but I just want to cover like a very simple case. Okay, did I just lose that? So it's a very simple app, and there's a routing setup to navigate between these two pages. Like here, there's a main component, about component that we have set up the routes for. And so, how would you test like a component or an app with routing setup? So the router again provides something called in the testing utilities for the router. There's a router testing module. And you can essentially have like you can export a constant that has the routes like we did in this case, and you can share the same routes between your application and the unit test, or maybe you might want to do something else. But just the same way we share like the module, you can also share the routes between your application and essentially you can simulate router navigation by saying, hey, just navigate by URL, and you can go to a particular URL. And again, that's operation that can be async, and so if you test for things immediately after you navigate by URL, it's not going to be there. So again, you either do when stable or you do take the fake async version. So so that takes care of like, and of course there's a lot more we can do with router testing. This is like just touching the surface. The Angular testing guide in the Angular.io site has a lot more scenarios for testing with routing. Yeah, I just wanted to touch this. I don't have a plunker. I didn't get a time to do a plunker for this one. But essentially, this is a common scenario that you encounter. Like, you have your component, and it has 3 other components. I mean, that's the whole point of components, right? So how would you how would you test this super component that has all these components within it? So there are 3 different things you can do. First thing is don't mock out anything. right? As in the components itself, maybe you want to mock out the services still. So we just say, hey, we just instantiate the component as is, and then we will take care of actually in your test. You would have to understand how those other components work so that you might have to locate some other element in those components to click them. But if that's something you want to do, like, yeah, you can do that. So that's one way of doing it. Again, it's closer to what you have in production. Maybe you feel comfortable doing that. But you can also consider mocking out all the dependencies of the component itself. So essentially, your component, which is app component here, has dependencies on these other things. So in your test module, which sets up the environment for your test, you can say, instead of using these actual other components, use these test components. And you'd have to write these other test components by hand, and maybe they have some hooks in them to say, hey, these components are called in the expected way kind of thing. So you could set up with that. Or you could say, I don't care how these other components are being called. I just want to make sure they are there, right? And in which case, you declare only your component, and you don't provide declarations for any of its dependencies, right? And by default, that's an error in Angular because it will say, hey, this tag is unknown. Like now that the template parsing is more stricter, it needs to really know what are the different tags that are there in your template. So you can say, hey, for this, I'm just testing. Don't worry, there's a no error schema. Just use that. So these are like the common patterns like you'd encounter and the strategies. Again, the Angular.io testing guideline is like has a much exhaustive list, and I encourage everybody to go through that and write unit tests. All right, thank you.